Okay, so today we are working on 10.6, and we're just going to be talking about more angle arc theorems. So Theorem 89, if two inscribed or tangent chord angles intercept the same arc, then they are congruent. So this is what it means. If I have an arc, so I'm going to draw an arc and put my endpoints, and we'll call those endpoints A, B. And hypothetically, we're just going to say that this arc is 80 degrees. If I was to draw two inscribed or tangent chord angles, those two angles have to be congruent to each other. Okay, so again, this is what it means. If I was to draw an angle like this, and then if I was to draw a second angle using that same arc with the endpoints of AB, this angle right here has to equal this angle right here. Okay, so again, if two inscribed or tangent chord angles intercept the same arc, those two angles have to be congruent to each other. So here's C and D. So if, again, because they're both intercepting AB, I don't even know how to put that, then those angles, angle C has to be congruent to angle D. So again, because they're both intercepting this pink arc, again, and both of them has to be 40 degrees. Obviously, inscribed angles are half as big as its intercepted arc. Those two angles have to be congruent to each other. Theorem 91, an angle inscribed in a semicircle is a right angle. And obviously, so if I was to look at arc AB, and so when I say arc AB, I can actually go either way because arc AB is 180 degrees. I can see that chord AB right here, the blue part, is going through the center of the circle. So if something goes through the center of the circle, if I'm going to draw an angle coming from the endpoints, it doesn't matter where, a triangle or an angle. So let's say I draw this angle right here. Because the endpoints are A and B and the arc is 180 degrees, this angle has to be 90 degrees. And it happens every single time. Try it. Use endpoints A and B. Draw from B down to somewhere on the circle. Doesn't matter where. When it hits the circle, connect that point to A, and you'll see that it makes a right angle. It's crazy, isn't it? And that is because, again, you can see I can do it again. Hit the circle, connect it to A. Oh, look, a 90-degree angle. That is because the arc that it is intercepting is 180 degrees. And when you draw an inscribed angle, it's half of its intercepted arc. So again, very straightforward. And then the last one, we're finally going to be talking about how we can figure out how big this angle is outside. So the sum of the measure of the tangent angle and its minor arc has to equal 180 degrees. So this arc, so AC, the arc, added together with this exterior angle, this tangent angle, has to equal 180 degrees. Okay, so again, hypothetically, let's pretend that this major arc, I don't know, let's call this major arc 220 degrees. If that major arc is 220, the pink arc would have to be 360 minus 220. Okay, so 360 minus 220. So we have this to be 140 degrees. If this is 140 degrees, if the pink arc is 140 degrees, then the angle that it creates has to be 40 degrees because the two of these have to add up to 180 degrees. Okay, once again, let's do another one. So let's say this time I tell you that the pink arc is 100 degrees. This angle then would have to be 80 degrees because again, these two, the minor arc and the tangent angle have to add up to 180 degrees. And that is it for 10.6.